everyone. Welcome back to my YouTube channel. My name is Aryan Puri, and in this presentation, I will walk you through Lab 8, where I explore probability and belief network. I will explain the key concept of independence and conditional independence and show how I use the AI space belief net tool with fire alarm example and share what I learned from this lab. Let's get started. So first of all, we have to uh, solve some preliminary questions. Our first question is about independence. Okay, so the two variables are independent when outcome of one does not affect the outcome of the other. So in other words, if you know the value of one variable, it does not change your expectation about the other variable. For example, if you roll a fair die and flip a coin, the result of the coin flip does not affect the result of the die roll. Okay. Now, our next question is about conditional independence. Now two variables can sometimes seem related, but when you know the value of a third variable, they become independent. This means that once you have that extra piece of information, the two variable no longer influences each other. For instance, if you know that a fire has started, the occurrence of smoke is not affected by whether an alarm went off or not. If the fire is already confirmed, that's all the key information you need regarding smoke, right? And now our third question is about independence in belief networks. Belief network, also known as Bayesian networks, use the idea of independence to simplify complex probability calculation. In these networks, each node is considered independent of other that are not directly connected to it. Once you know the state of its parent node, this allows us to break down a complicated overall probability into smaller, easier to handle pieces. For the hands-on part of this assignment, I used the AI Space Belief Net tool with the fire alarm example. Here's what I did. First, I acquired the chance of having smoke without any additional information. So the tool gave me a very low probability, only around a couple of percentage, because the likelihood of a fire is very small. Next, I set an observation that there is a fire. Once I did that, the tool uh, shows that the chance of having a smoke become very high. This makes sense because if there is a fire, smoke is likely to be present. Then I went step further by also observing that the alarm was sounding. Interestingly, the probability of having smoke remained the same as when I just observed the fire. This is because in network, knowing about the fire is enough to determine the chance of smoke. The alarm does not add any extra information about the smoke once we already know that there is a fire. This exercise demonstrates how adding certain pieces of evidence can drastically or dramatically change the probability of an outcome while adding redundant information like alarm when fire is already known does not change the outcome further. So, in addition to the simulation, I use the independence quiz tool to further explore conditional independence. For example, I checked whether knowing one event, like an alarm, could make two other events independent. So I found that in one scenario, One event did become independent while in another it did not. So to sum up this whole lab experiment, uh, this lab helped me to understand how belief network uses independence assumption to simplify complex probability problems. It also gave me practical experience in seeing how observation changes our expectation and how some pieces of evidence are redundant once other key information is known. So that's it from my side. Thank you for watching my presentation. Goodbye.